huge topic. Huge doesn't even do it. I'm thinking massive, mammoth, monumental, immense, colossal topic here in the voice over IP realm. And that is the idea of dial peers. Oh, wait, actually I remember. From one of the previous videos, which one was it? The ePhone. The ePhone video, an ePhone DNs. I gave it the second most important flag. Here is where we will now have the number one most important flag of the series. This is the idea of dial peers. In the previous video, we talked about how we can connect our routers to legacy voice systems through analog and digital voice ports. And we even got into how to connect to other voice over IP systems using H323, MGCP, and SIP, the voice over IP protocols. Dial peers is where the rubber meets the road and the configuration exists. This is what defines the links on our router to those other systems. The last video was theory and the ideas behind it. This is the implementation using dial peers. So as we go through here, we're going to talk about call legs, which is the idea behind dial peers, what dial peers are all about. We'll then look at the dial peers specifically, two types, POTS, plain old telephone service, and voice over IP dial peers to connect to the two different types of networks that we have. And then finally, we'll look at the dial peer wildcards and digit manipulation, all along having a live configuration scenario that we're setting up bit by bit using these dial peers. Now, I was looking at the slides I have before I started recording this, and I thought, you know, I don't think I'm going to make it. I don't think I'm going to make it through in a single nugget through all of these concepts with dial peers. So probably somewhere in the middle of these topics, I'm guessing somewhere between here and here, between the config and the manipulation. We'll take a break and break it into a second part 2 of this nugget. So without any further ado, let's get going. Now, dial peers, which is what this and the following nuggets are about, are a little strange when you first see them. They don't quite seem to make sense at first. So someone came up with this idea of call legs to try and describe how dial peers work. Call legs define the voice route path. This is kind of like data routing, as if this was a computer over here and it was trying to ping, you know, over on this side, we'll say 192.168.1.1, this computer over here. We would have a path to follow. It would go to its default gateway, it would look at the routing table would say go this way, and the router would receive it, look at its routing table and say, well, go this way. That's how we understand routing in the data world, and it's very similar in this call leg scenario. Any change in network type requires a new call leg. So instead of talking about data devices, a computer on the left talking to a computer on the right, let's talk about voice devices. We've got extension 1000 over here on the left that is trying to dial extension 2000 over here on the right. Now, we talked in the last nugget about FXS and FXO ports, and we're bridging this analog device using an FXS port to the router, and he picks up the phone. Here's dial tone. Dials 2000. The router gets it. So he's dialed this number, and this is now defining our voice path. Call leg number 1 dictates that we are going to connect from our analog phone over the FXS port to the router. Okay. Now the router is going to look at its voice routing table just like the data router did, and it says, oh, in order to get to 2000, my voice routing table is telling me to go to extension, I'm thinking voice, IP address 10.1.1.2. That's my destination. So we now have an IP call leg. I'm dialing 2000, okay, and that goes out here. It says I'm going to 10.1.1.2. Now call legs, you notice this third bullet here, are defined inbound and outbound. So I just place the call to 2000, and this is where most people get caught. They miss a call leg here because this router over on the right-hand side, we'll call him router 2, now has to receive that call coming into 2000. This dialed out to 2000. This dialed into 2000. So we have call leg number 1, which is inbound right here into the router. It then sent a call outbound across the IP WAN to 2000. This guy received the inbound call saying I'm now receiving 2000, and then it's got a call leg going out right here making 2000 ring, ring, and they answer their phone. So this is showing one path, one source to destination path for the call leg from extension 1000 to 2000. Now if we were to dial exactly the opposite, we would have the call leg number 1, and I should put numbers here. This is number 1, number 2, number 3, and number 4 call legs that are going out this way. We would have call leg number 1 coming in here. He dialed 1000. It would have an outbound number 2 going right here. He would have inbound number 3, and then an outbound, oh, I'm falling off my pad here, outbound number 4 that would make this phone ring. So in essence, when you're looking at this, you have 8 different call legs, 4 in each direction, that define end-to-end calling in this scenario. So when we're talking about call legs, and I'll just focus on the one direction here, right here. We'll say number 1, number 2, number 3, and number 4 that is coming into this phone. This is what defines our end-to-end communication. Now the reason I bring up this call legs, this theory, if you will, of how these connections happen, is because this is exactly how we have to configure our dial peers on a router moving into the configuration to define end-to-end calling. We can now translate that call leg theory into something practical, and that is dial peers. There are 2 types of dial peers that we're going to encounter, and that is POTS or voice over IP dial peers. POTS dial peers are used to connect to any traditional telephony network or devices. So, if I have a router connected through a FXS port to a phone, that would need a POTS dial peer, and that would define essentially the phone number for that phone. The phone doesn't have a phone number just by plugging it in. We have to give it one. This would require a POTS dial peer because it's legacy. If we have a FXO port connected to the PSTN, that would be a POTS dial peer, either to govern outgoing calls to the PSTN or incoming calls from the PSTN. It needs an FXO dial peer. We then have our T1 lines. Now that seems kind of funny when we think about it, because we think T1 is kind of newer, data-y kind of thing, but not really. Our T1 lines are just digital connectivity to the PSTN or maybe a PBX system, and those would require a POTS dial peer that defines reachability information. So the way you know you're configuring a POTS dial peer is anytime you're defining numbers that are reachable through a given port. Keyword port. And we'll see the configuration in just a moment. I'm saying to get to this phone number, go out this FXS port. Or to get to the PSTN, go out this FXO port. That's actually the command we use. Port, port. We're always going out a port. Voice over IP dial peers, on the other hand, define connectivity across any packet-based network, any IP communication. We know we're using voice over IP when we're defining numbers reachable at a given IP address. So take the scenario that I showed just a moment ago on those call legs. We had 2 phones that had our port, our FXS connection, our POTS dial peer, but in the middle we had this IP communication. And I said I was going from 10.1.1 to 10.1.2 over here. So to define that reachability information, I would need a voice over IP dial peer, because that is going to be reachable at a given IP address. I'm going from this IP address to another IP address. So my target is an IP, it's not a port. So now let's take these concepts and apply them. What I have here is the network diagram we're going to camp in for the next little while as we talk about POTS dial peers. What we've configured so far is up to here. This is our CME router that is connected to our ePhones down here. We've got set up with the 10XX extensions that I have running. We've got the connection from this CME router, and this is what's new. I've set up a WAN link, a serial connection from the CME router to what I've named the legacy voice router, which has traditional connections. We've got FXS ports connected up here to legacy analog phones, and we also have a voice T1. This is a T1, we'll set it up as a CAS connection for now, going to the PSTN that is able to receive and send calls to the PSTN. Now we've set up to here This is everything that we've configured in our previous one, our features, our ePhone, our ePhone DN. And we're now going to set up a voice over IP dial peer to connect up to this legacy voice router, which will have POTS dial peers connected to our analog phones and to the digital PSTN connection. So what I'd like to start with is this router up here. We'll kind of put this guy on hold until we get to voice over IP dial peers and start up here with our POTS dial peers. Now, what I've done, and I'm a little ashamed to show this because it shows a small piece of what I've got connected. My wife has begun to hate this series. She always goes, "Are you done with that office destroying series yet?" Because I actually, this is my pen I'm drawing. I've got over here my racks of equipment. This is just 3 out of the 15 routers or so that I have stacked up above. But what I've done is I've actually, I'm not going to draw. I've got RJ11 cable, just phone line cables that are strung from this rack over here, and I also have, you can see just this mess of cable. This is just a small piece of it that is connected here. These are my 2 analog phones. In this picture, this is 3301 and 3302. And I'm going to bring up my connection to this legacy voice router and do a command that I love this command, show voice port summary, and hit enter. And you can see that I have 2 FXS ports installed in this router. I'm not showing you the T1 connection yet. 2 FXS ports in this router that are installed. It shows they are both currently on hook. And these are the ones that are linked. This is actually the cables right here. I know it's very small to see. That are linked over here to these phones. When I pick up this phone right here, set it over to the side, I'll do the show voice port summary. It shows it is operationally up. It is off hook. If I pick up this one right here and set it to the side, hit the upper and do that command again, it shows both of them are now off hook. So essentially I can see that this one right here is connected to 1/0/1, and this one over here is connected to 1/0/0 because it's still the one that's on hook. So I have some active voice or analog devices that are plugged in there. Now if I were to listen to them, if I were to put this up to my microphone, we can't hear it. It's too soft. It's giving me dial tone as of right now. I can hear them, but as of right now I cannot dial between them because there's nothing defined. That's going to be where my POTS dial peers come in. Let me scoot this video out for a moment, and I'm going to go into my router, move into global config mode, and let me walk you through the syntax. I'm going to type in dial peer. Now hit the question mark, and you can see there's many different dial peers we can create. The one we're going to talk about in here is voice. We're not doing terminators or class of restriction. This is some of the stuff I talked about earlier when I was talking about the ePhone productivity features, and we talked about the restrictions that we can put. Class of restriction is one way that we can do it. But I'm going to say dial peer voice, do a question mark, and you can see it says, what is the tag? Now the tag is just a logical identifier. You can see it's from a large range of numbers, 1 to 2 billion something, and this is just a logical identifier that I can give this on my router to identify this dial peer uniquely. The number you can pick can be anything as long as it's unique on this router. It's unique for each dial peer. Now it's a common practice to make this tag equal to the phone number, if I'm assigning one phone number, that I'm assigning. Now it doesn't have to be this way, but usually if I'm going to make this for 3301, I'll say the tag will be for 3301, just so I can see it and identify it. Now I'll do a question mark, and it says, well, what kind of dial peer is this? And you can see that we have voice over IP, we have POTS. Those are the 2 big ones. In the old days, and they still support these configurations, we could do voice over ATM and voice over a frame relay. That was if you were learning the voice world back probably, that would be, 6 years ago? People don't do that anymore because, even if you run frame relay or ATM, we run voice over IP over frame relay networks. We don't actually point to DELC numbers as our endpoints. So I'm going to say, in this case, we are configuring a POTS dial peer. And remember, this is because we are configuring a dial peer on my legacy voice router that will go over here to 3301. And then we'll configure a second one over here to 3302. So I'm in dial peer configuration mode. 2 big commands you want to know, and that is, first off, destination pattern. This defines the phone number that I'm going to assign to that voice port. In this case, it's going to be 3301. The second big command you want to know is what port. Remember I said POTS dial peers always point to a port. Well, in this case, when I did the show voice port summary, 1/0/0 was actually the voice port. Now, before I type in that voice port, let me talk about where that comes from. In this picture right here, I'm actually using this router. I can't draw on here, but it's this router right here. It's a 2600 series router, and if I were to draw it up, let me get this out of the screen. The 2600 series router, in a rough sense, looks like this. We've got two fast Ethernet ports. Technically, this is actually a 2621XM router. I've got fast Ethernet 0/0 right here. Fast Ethernet 0/1 right here. And then over here I have this big voice module. The actual model number of it is NMHD-2VE. It handles two voice modules. Now inside of here, in the left module, I have a VWIC 1 MFT T1. This is my T1 interface that's going to connect to the PSTN. The voice module right here is actually a VIC 2-2FXS. So when I'm looking at it, there's actually two voice ports that's on it. So when I do that show voice port summary command and I see that I have port 1/0/0 and 1/0/1, let me bring this back over to the screen. This one is actually 1/0/0. Here's why that is. The first number of this represents the module number. On a 2600 series router, everything to the right, meaning these fast Ethernet interfaces, there's two WIC cards over here, these are all considered, this whole clump of them is considered module 0. That's why we call it fast Ethernet 0/0. This is module 0, port 0 for my fast Ethernet port. So everything over here in this module is considered module 1, and that's where that 1 comes from. Now you'll notice in this module, if I'm looking at it, and this is again my tiny view, this is the whole module. There are two, and this is microscopic, so I know you can't see it. There are two modules inside of here, two VIC cards or voice interface cards. The first one is considered VIC card 0. That's this one to the right. The second one is VIC card 1. That's my little T1 port over here to the left. So when I'm looking here, the second number on this represents the VIC card. So module 1, VIC card 0. This is VIC card 0, this is VIC card 1. And then the final number represents the actual interface number. So this port is port 0, this port is port 1. And I know it's starting to get a little cumbersome to see. Let me grab a different color here. This is 0, this is 1. So when I'm looking at the syntax here, it's actually saying module 1, VIC card 0, and then port 0 of that VIC card, and then this is port 1 of that VIC card. That represents my individual interfaces on there. So when I'm looking at my ports right here, this one is actually 1/0/0, and this one is 1/0/1, FXS ports. So when I'm configuring this dial peer, I can type in port 1/0/0 for that first one. I'll exit out, hit the up arrow a few times, create dial peer voice 3302, destination pattern 3302, port 1/0/1. So at this point, I've used POTS dial peers, you see that right here, to assign 3301 to FXS port 1/0/0 and 3302 to FXS port 1/0/1. I can now grab my phones. Let me bring up my camera so I can prove this to you. I can grab my phones and type in, pick up this phone. Hang on, this one was 1/0/0. I can dial 3302 on this. Now I don't know if you can hear this. I'm putting my mic up to it. That's my face. I'm putting my mic. The phone is ringing. Matter of fact, we can even go one better than this. On the router, I'm going to do a debug VoIP dial peer. And we can watch it as we dial. I'm going to pick up this guy. and dial, and you can see as it happens right here, when I say this guy, I mean this phone. This is 3302, and I'm going to dial, hang on, I'm probably getting the reorder tone. I'm going to dial 33, and let me flip back here. You can see I've dialed 330. It's going to come up. Shows I've now dialed 3301. And as soon as I do that, you can hear this other phone ringing. Right here, let me put this down and answer the call. I now have an active call going between these two routers. If I do a show, what is it? Show voice. Is it active? No, it's voice call. Summary. There we go. Summary of all voice calls. It will show there's actually a connection, voice over IP state. We are connected between FXS port 1/0/0 and FXS port 1/0/1. Now, as soon as I grab these phones, here we go. Grab these phones and hang them up. If I go back here and do the same command again, show voice call summary, it shows that I'm now on hook. I'm no longer connected between those two. Technically, in terminology world, Cisco calls this a local call. Local call. That is a call between two devices attached to the same router. I know that's a terminology shift because we're used to calls going to the PSTN that are not long distance being considered local call, but Cisco actually calls those off-net calls, meaning we're going off our network. So this is considered a local call between those two devices. So that is POTS dial peers, at least between FXS ports, two analog devices. Now, before I configure this PSTN connection right here, and we get into the digital voice port, I want to move down to the CME router and get some voice over IP connectivity going. Now, as we move into these voice over IP dial peers, I want to also introduce some of these wildcards. So I'll introduce them as we configure. I'm going to be down here on the CME router, bring up my connection, and as of right now, this is managing all of our ePhones and so on, and they have no idea how to get to the remote phones up here. We've got 3301 and so on. So, for example, if I were to pull this up, hit this, I'd get dial tone. I start dialing 33, and it, right there, unknown number, and you're hearing a fast busy signal in your ear because it has no idea how to get there. So, what I'm going to do is go into my router, CME router, and create a voice over IP dial peer. Same syntax as before. I'll do dial peer voice, and tag number again can be anything. I'll make it 330, just because that's encompassing the extensions that I want up there, 3301 and 3302. Actually, let me scrunch this down a little bit. So there's my 3301. So I'm going to go to 330 and do question mark and do voice over IP, because now my CME router is connecting over the voice over IP network to get there. Then it will use the POTS dial peers. Now remember, this is kind of a call leg thing. We've got the voice over IP call leg here, and then this will shoot up here and use the POTS dial peers to reach these two devices on top. So where am I? I'm going to do voice over IP. So same thing as before. I'm going to do destination pattern, but catch this. I'm either going to have to make two voice over IP dial peers, one for 3301 and one for 3302, or I can start using these wildcards to help me out. Now, I'm assuming that this is a partial picture of this network. It might not be, but I would assume if I had 3301 and 3302, there's probably other 330 things up here. Maybe some other analog phones or other connectivity to 330 devices. If not, then this wouldn't work out okay. But for now, what I can do is do destination pattern 330 dot. The dot, as we saw right here, represents any one digit. So I can have 3301, 3302, 3309. Any one digit that I dial there will be represented by that dot wildcard. So that's a way to save myself some configuration, and I'll tell you what, that's very handy when we get to the PSTN, because the PSTN is a massive place to be. So I'm now going to exit out. Oh, and by the way, in voice over IP, the default codec is G.729. So if we want to change that, we could change to G711 ULAW or whatever. I'm going to leave it at G729 so we can use some compression, save some bandwidth going over the WAN link. So now, at this point, if I were to pick up my phone right here, my little IP communicator, and hit the button and dial 33, oh, says unknown number. I'm hearing a reorder tone. Oh, I'm still in the configuration mode. Let me exit out and let me do a show dial peer voice summary. It's a great way to see my dial peers. You can see that I have my dial peer, lots of them, up here. I'll explain those in just a moment. For 330 down here, voice over IP shows destination pattern is 330 dot. Oh, I'm not done yet. Big dummy, what am I thinking? Let me do a show run, and I'll do a section dial peer. Show me the dial peer section. But before I dive into what that's all about, I do want to show you that we do have all these dial peers. CME automatically creates dial peers, POTS dial peers. It seems kind of odd that it would do this, but POTS dial peers for every single ePhone DN that you create and assign to a device. That's how it relates to those. It's like virtual POTS dial peers to make your phone rings. It's kind of odd. So that's what we see right here. Down here, we see my voice over IP dial peer, and I told you I'm not done yet. I just got so excited after this destination pattern. We're saying for this destination pattern, nothing. That's why it shows it is down right now, because I haven't actually told it where to go. And where to go is known as the session target. It's saying, when I'm dialing this, and the router's going, yes, what are you doing? This dial peer, by the way, I created, I think, to just show the codec example when I was showing you bandwidth calculations. So I'm actually going to delete that one. I'm going to do a no dial peer voice 50, voice over IP. So that one's gone. And we'll go back into this guy right here. Voice 330. So I've told it the destination pattern. Now I need to tell it where to send it. And that is done through session target. I'm going to say session target is, and the place I'm going to send it is right here. I'm going to go from my CME router up to this router, 10.1.1.2. Now, unfortunately, the session target command is very funky. If you hit the question mark, it says word, a string specifying the session target. The exact command that I need to type in is IPv4, meaning I'm sending it to a IPv4 address, colon 10.1.1.2. Meaning that is the destination that I am sending it to anytime somebody dials 330 dot. Now, you can see this is very vague. It's like word. You're just going to have to remember IPv4 colon. They do have a very rudimentary context-sensitive help. Like if I were to just mess something up here and type ASDF, this is ugly. But it says must be of the form, all this junk right here. This is one of them, IPv4 colon, and it shows you can type in an IP address dot, and all that stuff in here. I don't know why Cisco didn't do a better job of the context-sensitive help with this command, but biggest thing to remember right there is session target IPv4. So now when I go back and do that show dial peer voice summary, I can see that I have dial peer 330. Notice it is now up. You remember that was down before because I didn't have a session target. So it's saying anytime you dial 330 dot, it will go there. So I can go back over to my IP communicator. Let me go ahead and bring up my my little camera as well. Man, I cram so much stuff in this little screen. I'm going to hit the dial tone and do 3301, which is now ringing this analog phone. I'm going to reach over here and lift it, and now you can see it is connected. It says unknown number. It flipped over to unknown number here because I haven't actually assigned caller ID information to these phones yet. So I'm going to put that guy right there, flip back over to this. Look at all these active windows. And now I'm going to do a show call. Oh. Show voice call. And we'll just hit enter. Let's do summary. You can see it showing all the different ones. And right here, this is the dial peer representing my ePhone. And it's showing that it is communicating, it is connected via G.729, that's the codec that it's using, over to the other side. Okay, and it shows this as a connect state. All the other ones are currently on hook. Now, if I were to hop over to my legacy voice router and do that show voice call summary as well, it shows that just that FXS port is connected using G729 codec to the other side. Notice it also says VAD is enabled. Remember what that is? Voice activity detection. If you remember from when we talked about voice codecs, I talked about this is a way to save bandwidth. Anytime there's silence on the line, like that, it's going to cut out the bandwidth so it's not actually sending all of the bandwidth that's there. So we now have a active call established between, or essentially from, my voice router right here and one of my IP phones, 1005, up to this guy. But the problem is, these guys up here, or I guess right here, window madness, are not able to dial back. If I were to hang up this line, and and let me bring up the access server, if I were to do a debug voice over IP dial peer, right here, and I were to pick up the phone and dial, you can see it, and I pick up the phone and dial 1005, type it in, and you can see called number 1, and immediately, and if I were to put this phone up to the thing, I'd be hearing a reorder tone, because you can see immediate result is no match. I dialed 1005, but it stopped right after 1, because when I do a show VoIP dial peer, show voice dial peer. Oh, sorry, this one has a different iOS. Show dial peer voice summary. You can see that the only thing this legacy voice router knows how to get to is 3301, destination pattern 3301, and destination pattern 3302. Meaning that as of right now, we've created a one-way voice path, if you will, or a one-way dial path, where I'm connecting from CME to this router, but I don't have one going back. This is, we need it for two-way voice. So let's create that. I'm going to go into my legacy voice router, into global config mode, and I'll do dial peer voice, and we'll just do it 1-1, because all of the extensions down here are, 1-0, and we'll create that as our dial peer number, 10 VoIP. Remember, this number is just a tag, just has to be unique on the router. These are the tag numbers. What actually defines the numbers that are reachable is that destination pattern. So we'll do destination pattern 10 ... right? Because all of the numbers down here are 10 something something extensions that I've created. So I'll say 10 ... is reachable through the session target, and finish that statement. What would you type there? Session target IPv4 : 10.1.1.1, because we're going up here from this legacy voice router down here to 10.1.1.1 as the session target. So bring that back up here. Session target IPv4 : 10.1.1.1. Enter. Now when I go back and do that show dial peer voice summary, you can see that I now have a new voice over IP dial peer that's up. It's going to 10 anything, or 10 any two numbers, and it's going to 10.1.1.1. So let's try this out. I'm going to bring up my IP communicator right here, and let's go ahead and bring up the little video window. Why not be, well, hang on, I've got this always on top application that tries to put things always on top. Let me see if I can make this go always on top. There we go. Let's see if stuff going everywhere. Minimize. Go up here. Okay, there we go. No, it's not always on top. There we go. Can I fit it all? No, not. I clicked on the mostly sunny. Now look at this. I'm getting Netflix pop-ups. AccuWeather. I'll tell you what. Let me go back to my video camera, please. There we go. I've got them all in one page. So now I'm gonna go to my IP communicator. Is that what I'm doing? What am I? Okay, I'm gonna go to this analog phone. Pick up the analog phone and dial 10 0. I've got the debug. You see it? It's not saying no match. 1 0 0. There's my third 0. So called number right there. 1 0 0. Oh, I lost the video. 5. And as soon as I dial that, it shows matched destination right there. Called number 1005. Outgoing dial peer tag 10. Go back to that show dial peer voice summary. That's this guy, which goes right here. And now you can see up on my IP communicator, it's receiving an incoming call from my analog phone up here. My word. Did you follow that? If so, I am amazed at your ability, because 4 windows with the diagram all in one place. So we have now created, let me just summarize this. We've created a dial peer, a voice over IP dial peer. Actually, let me summarize the whole thing. POTS dial peer is going to these guys. We've got voice over IP for 10 ... So anytime one of these dials 10 something, we go down here. We created a dial peer on this guy saying anytime somebody dials 330 ... send it up to here. And now we have two-way voice over IP communication between these two. Now, the last thing I want to do before we go on, I've talked about the wildcard of dot, which is what gave us the ability to do this, 10 ... But there's some other wildcards that you can work with that give you some flexibility as well. You've got plus, which I very rarely use. Plus is one or more instances of the preceding. So, for example, if I created a destination pattern of 1 plus, that will, if I said destination pattern is 1 plus, that would be 1. 1 would be match that because it's one or more of the preceding. 1 1 1 would match. 1 1 1 1 would match. 1 1 1 1 1. You get the idea here. So, anytime somebody dialed 1 1 or anything beyond that, it would match that destination pattern. That's what the plus does. If I created a destination pattern, oh, this one's worthy of some discussion here. Let me do this. Wipe all of that off of there. The one, or I should just say brackets, represent a range of digits. So if I were to do, for instance, bracket 1 through 3, 1 1 1, on the route as my destination pattern, if I put destination pattern 1 through 3 and then 1 1 1, that would actually give me an actual match of 1 1 1 1, 2 1 1 1, and 3 1 1 1. It would match any of these dialed numbers. Anything that I put in the brackets represents one dialed digit. It could be, 1, 2, or 3 based on that range. So, if I created a destination pattern of, we'll say, 1 1 bracket 4 through 6 bracket 1, this would actually match 1 1 4 1, 1 1 5 1, or 1 1 6 1. Now, just to make sure, the reason I emphasize this just represents one digit is this does not match 1 1 4 5 6 1, right? Because this is just one digit. So it matches these three. It does not match this one, right? Got that? So the reason I say this is worthy of some discussion is because you can get a little wild with this. I could do 1 through 2 ... combine some wildcards there. So what this would be, maybe I have up at this office, all 1XXX and 2XXX extensions. This is one way that I could create a single destination pattern that matches all of those. So destination pattern 1 ... and 2 ... would go up here. All right, get ready for this one. I could have a destination pattern of, we'll say, 1 2 through, well, hang on, no. Let's do 1 4 through 6 1 1. Okay, it looks like 14 through 6, but mentally in your mind, anytime you see digits next to each other in brackets, put a comma in there. Okay, what this actually matches is 1 1 1. Remember, this is 1 4 through 6. 4 1 1, 5 1 1, and 6 1 1. It actually matches these 4 patterns, because when I say, and let me write it up here so it's clean, 1 4 through 6, that is actually, mentally I say put in a comma, it's actually 1 or 4, 5, or 6 as that number. You could see a pattern like this. You could do bracket 1 3 5 7 bracket 1 1. And that would actually match. You could mentally, don't type it in because it won't work, but you could mentally think, that is 111, 311, 511, and 711. It's like little commas in between. So you can imagine on a certification exam, Cisco's going to want to trip you up on these kind of things. They want you to know the nuances, and you can actually use these. They're useful. You could have a 14 through 6, 9 in brackets, 1 1, which would match 111, 411, 511, 611, or 911 as potentials. I know I'm getting sloppy right here, but just to show you the different possibilities with these brackets. That's how those work. The last wild card that I'll talk about, and then I'm going to wrap this up. I know we're going long in this nugget. I've got to cut it off. It's the T wild card. T wild card is your generic bland wild card. It can match anything, any number of digits. So, for example, what I would call a lazy PSTN dial plan might be 9 for an outside line, destination pattern, 9T. Which is any number of digits. So if somebody dials 9, and then any number, 911, 480, 555, 1212, anything matches this. It's any number of digits, 0 through 32. The problem, and the reason I say this is a lazy PSTN plan, is because if it matches any number of digits, I could dial 9 and then nothing after it, or 9 and 32 digits after that, and that's what this represents. How does the router know when you're done dialing? If I dial 911 or 9480 555 1111, how does the router know? How does it know when I'm done dialing? How does it know when I'm not going to dial more after this? The answer is it doesn't. It's just going to wait there until you hit what's known as the inter-digit timeout. On some routers, it's 10 seconds by default. On some, it's 15 seconds. So you actually have to wait, if you use the T wildcard, 15 seconds after dialing that number, potentially, before the router says, okay, you're done dialing, I'll process it. Now, how many users do you know that are patient enough to wait 15 seconds after dialing a number? None. In my mind, nobody's that patient. They'll hang up and be like, oh, it just doesn't work. You can speed things along by pressing the pound symbol after you dial. That tells the router you're done dialing and to process the call. But again, now we're talking user training. Oh, hey guys, anytime you dial a PSTN number, use the pound key to tell it you're done dialing. People aren't going to do that. So the T is not very useful. Well, I guess it can be, but in this case, it's not useful for a PSTN dial plan. I'll show you in the next nugget. I got to cut myself off here. I'll show you in the next nugget how we can create a PSTN dial plan using these other wildcards rather than the T. So let's wrap up this portion of the dial peer discussion. We have now seen call legs, and seeing the configuration almost gives more meaning to the call legs, because you now can see, we've got these individual, I guess you could call them hops to devices. A POTS device needs a POTS dial peer, or is a POTS call leg. Voice over IP needs that outgoing IP dial peer, and so on. That defines, I always call dial peers, the routing table for our voice. When we're making voice calls to and from different locations, they are what give the router the intelligence to do that. Now we got up to, in this nugget, the dial peer wildcards, started talking a little bit about those, but I still have more to talk about and expand on that scenario, set up that T1 line to the PSTN. All of those go into the wildcard plan as we plan out our POTS and voice over IP dial peers. So more on this in the next nugget. Up till now, I hope this has been informative, and I'd like to thank you for viewing.